Hi everyone, so today we would like to present the availability study on gas processing plant for MDB4433Z. Our group consists of 5 members including Aisa, Sheila, Shira, Abu Amirul and Awatif. Reliability, availability and maintainability have become the focus of all industry in present time. Tighter budget, shorter cycle time and ever-increasing demand for better, cheaper and faster product has created awareness on the usage of engineering reliability tools. With increasing complexity of industrial system and widespread use of powerful machine and equipment, reliability simulation become preferred solution such as Weibull++ and BlockSim. The usage of analytical approach take a lot of time and delay work.
For the next part, one such simulation-based approach that is now being regarded by many industries as standard of reliability engineering is RAM analysis. This chapter illustrates the applicability and benefits of conducting RAM analysis of industrial systems by considering the examples of natural gas processing plant. For the objective, firstly, we can predict the availability of the natural gas processing facility under consideration. Next, we can identify the bad factors or the key components responsible for the loss in availability and production. Moreover, we can identify recommended actions to improve performance. Finally, to estimate the expected availability and production if the recommended actions are implemented.
So now, I would like to explain the methodology of this project. The first methodology is to define assumption of analysis. RBD block in white, including standby container block, are neglected in this analysis due to non-failure properties. Performance improvement is defined as the increase in each failure time of the equipment by specific percentage. The gas processing plant is defined as a system. The individual equipment to form the gas processing plant is defined as subsystem, and the equipment to form the subsystem is defined as component. The second methodology is to assess the distribution parameter for each equipment. Power law are used to estimate the beta and lambda of each equipment. The NTBF of equipment used to obtain value of beta and lambda. The time frame used in this experiment is final observation time and 3 years after final observation time. The third methodology is to assess each subsystem availability. It is calculated by the formula MTTF over MTTF plus MTTR. The calculation depend on the configuration of the system. The subsystem is reduced to a single block to obtain the overall availability. The fourth methodology is to assess overall gas processing plant availability. After assessing each subsystem availability by using the series and parallel model, then we can calculate the overall gas processing plant availability using the same method.
To identify the vector towards the system, each subsystem's availability are arranged in ascending order to critically rank the bottom 5 subsystems that has the lowest value in availability. The bottom 5 systems are chosen as the back actor in the analysis for further improvement for the process. To improve the back actor availability, the improvement step will begin with the subsystem that has the lowest availability figure. The improvement process is carried out by increasing each failure data of a selected component of a subsystem by a certain percentage. This will provide a better distribution parameter and also a better MTBF. Finally, after the improvement process, the overall gas processing plant availability are reassessed. The target of the gas processing plant availability is 99% of availability. Hence, by improving the bottom 5 critical systems, the overall availability of the gas processing plant can be improved.
So now, let us see the sample calculation inside this project. Here are the sample calculation for the NGL recovery unit system. Firstly, the assessment of distribution parameter per equipment is done. By utilizing the failure and repair data of a gas filter as shown inside the table here, the cumulative time between failure TBF was calculated and each value of the cumulative time between failure is factored by the natural log to obtain the required value to be utilized in the formula. From the data, the number of failures is 5 failures. The natural logarithm of cumulative final observation time, ln t, is 9.175 days. Meanwhile, the summation of natural logarithm of cumulative observation time is 40.5502 days. To obtain the mean time between failure, the equation below is used. The mean time between failure of this system is 2062.9289 days. Next, to assess the availability of the equipment, the ratio of the MTBF and summation of the MTBF and MTTR is calculated, as shown using the formula here. The availability of the system is 0.999. So once all the reliability and availability of each equipment are obtained, the series parallel model is used to calculate the average availability of the NGL recovery unit system. The following equation and formula is used, obtaining the availability of the system to 0.9935. By applying the steps mentioned previously to each one of the equipment in the plant, we can obtain its average availability and reliability as shown inside the table here. By applying the series parallel model, we could also remove unnecessary block and simplify the reliability block diagram of the gas processing plant as shown here. The overall availability of the system is calculated using the formula shown, obtaining the availability overall of 0.988.
Now, we will continue with recommendation. Firstly, the right critical equipment, or known as the bad actors, should be identified after getting the overall availability. This can be done by arranging the equipment with the lowest to the highest availability. Then, the critical equipment should be improved. This is to help the availability of the overall system to increase and can reach the expected availability, that is 0.99. Next, a correct series parallel model are important to avoid mistakes in calculating the availability. Lastly, the assumptions established should be logical and clear. It is to help smoothen the calculation process. In conclusion, the overall system of the plant managed to be increased from 0.9881 to 0.9905. To achieve the expected availability, the top 3 critical equipment should be identified and improved. By then, it can help to increase the overall availability.